Hello everyone and welcome. It's Hugh here at Loxon and I'm here with our video looking at the solution for our earlier config challenge. So I've got it here just as a reminder. Today is Friday Fun Day for us. There will also be a prize for the winner of this challenge. So I've already collected everyone's config files who submitted one, and the winner will receive themselves a smart socket in the post. So our challenge today was, as an exasperated parent, to try and keep my children in line and doing what they're told, I give them a daily limit of how much TV they can watch. This, however, invariably leads to pleading and bargaining with me so that they can get an extra few minutes on the TV, whether that be that they don't want the 2 minutes they went to the toilet to count, or they've been really, really good today, so they want a few extra minutes. Therefore, I want to automate this because computers and robots and automation does not have emotions, and exactly at their 2-hour point, it'll cut them off. So the details. I want to have the ability to see who is watching the TV. So whose TV time is it? Is it the children's TV time or my TV time? If it's the children's TV time, then when the TV gets turned on, it should recognize that it's their time and the TV is on, and it should start counting down their allotted amount of time, which is 2 hours. 5 minutes before their time's up, it should read a text-to-speech message out of the speakers to say that 5 minutes left, time's coming up, get ready to go to bed, whatever. Once their 2 hours is then up, the TV should turn off. And as the adult of the house, I should have the ability to turn the TV back on through the app, but they should not. And then obviously every day this needs to be reset so it begins again from the following day. And then as the extra challenge, I said, occasionally, just ever occasionally, the children are good. So I want a TV coin button in my app that I can press that gives them an extra 5 minutes every time I press it. So now that we've got that out of the way, let's get started. So under the details, the first thing I've said is I want to have the ability to say whose TV time is it currently? Is it the children's or is it mine? So I need a way that I can switch between two modes. For me, the way that I like to do that is with a radio button. So I'm going to put a radio button down. On the radio button, I am going to make output 1 as adult time, and I'm going to make output 2 as children time. I don't want to have an all off. So in the radio button, I also want to say that there's a maximum of 2 outputs and that it can't cycle through to off. Now, because I've already prepared my demo case over here with the winner of today's challenge, and I'm not going to save into it, I am also just going to stick a input into input 2 of the radio button so that I can show you this in simulation as well. And so the next thing I need to do is, if it is the kids' time, I need to then look at whether the TV is on or not. And so to do that, easiest way, smart socket and the power measurement from the smart socket. So I need to take the power and I need a function block that recognizes whether that power has gone high or not. So I need something like a threshold switch. So my power into a threshold switch, and then I could say it's on when it hits 200 watts. And when it goes below 20 watts, it's back off again. And that would then output that. And then the next thing I need to do is I need to say that both output 2 and threshold needs to be true. So my next bit is going to be an AND block. So I'm going to have my threshold switch and my radio button into that AND block. I'm also going to rename this radio button to TV mode. For some reason my mouse stopped working then. TV mode. There we go. So now if it's TV mode, children's mode, and there's power to the TV, this output will go active. And so what I want to do with this output is I want to take this output and start counting it. Now, I could do this in several ways. I could do up and down counters. I could do a maintenance counter. So I saw a few people use the maintenance counter because you can set a time limit on it. I'm not going to, however. I'm going to use a utility meter. Because on a utility meter, I could trigger through a certain number of pulses, and it's already got a pre-built output for consumption today. which resets at midnight every day. So I don't have to worry about coming up with extra logic for resetting it on a day-by-day basis. But what I do need to do is, because the utility meter looks at triggers, at pulses, for a number of, for the units of whatever it's counting, I need to convert this permanent on into pulses. So what I need to do is I need to put the AND block into a pulse generator. And then with this pulse generator, I can freely determine how often I send pulses. So I could send a pulse every second if I wanted to. I could send it every 10 seconds. I could send it once an hour. I'm going to go for a number that doesn't require me to do too much maths later on. So I'm going to send a pulse once every minute. So I'm going to do a half-second pulse every 59.5 seconds. So a pulse every minute. And that is then going to go into the trigger of my utility meter. Now on the utility meter, I need to say the number of pulses equals how many units. Now, because in my overall scenario, I've said that I want a text-to-speech 5 minutes before it goes off, and I want in the extra challenge to be able to give them extra 5 minutes of time, I probably want the utility meter's whole numbers to be in periods of 5 minutes. So if I'm sending a pulse every minute, 5 pulses equals 1 unit on this. And that is the way that I'm going to do it. And so the next thing I need is from consumption to day, so AQ1, I need to work out 5 minutes before their allotted time is up, and then exactly what constitutes their allotted time. So if I just open up a calculator, we have 120 minutes in 2 hours. Now, I have separated the units that come out of here into 5-minute intervals. So there are 24 5 minutes in 2 hours. So essentially, what I need to say is when AQ1 is equal to 24, that means that time is up. And because I said I was doing this in 5-minute intervals and I want to do a text-to-speech 5 minutes before their time is up, that means that 23 units is 5 minutes before their time is up. And so there we go. We've got time up and 5 minutes before time up. How wonderful is that? So 23 is going to be my text-to-speech. Now, I am going to actually not put a status block there to do the text-to-speech. I'm actually going to assign it to an operating mode. I'm going to have an operating mode called 5 minutes left and assign that equal block to there. Because for anyone that's watched my focus series, you'll see one of my focus series was on the autopilot designer. And my preference for text-to-speech is to use autopilot designer. So in the autopilot designer, I would say event, 5 minutes of TV left, operating mode becomes active. Text-to-speech message, you've got 5 minutes left. And that's how I would do my text-to-speech. The next bit I'm going to need is I'm going to need my switch to say whether the TV has power or not. So I'm going to need a switch block. That can just drop there. And obviously I want my relay for the TV to be on said switch block. And then I'm going to want an on and an off on this switch block as well. And what I'll probably want to say is any time that it's the adults watching TV, this switch block is just on by default. I also want to reset this switch every day because I said part of it was a reset every day, and we actually have pulse for day. So at midnight every day, we can pulse to turn this switch block back on. We could also take a pulse for start. So there we go, start pulse, which pulses when the mini server first starts. So in case the mini server ever has a power cut, it just makes sure that the TV is on. And then this equal block here, the 24 equal block, that's our reset. So that is when the TV turns off because their time is up. And so before I move on to the extra stuff, let's look over what we've got. So actually, I know that I said I wasn't going to save this into the mini server, just so that I can show you that I'm not cheating you out of anything with the text to speech. I'm going to connect to the mini server. I'm going to just dump in a zone of music somewhere on this page so that we've got a zone there. And I'm going to save this config in just to show you Autopilot Designer and me doing that text to speech. So you can see my equal block. When that mode becomes active, then I want to do a text to speech. So here we go. User interface, Autopilot Designer, add a new one. The event is going to be operating mode, 5 minutes of TV left becomes active. Then the action is going to be music in the living room, text to speech message, not percent, 5 minutes left of TV. There we go. So that is how I generally prefer text to speech, because then it's very, very easy to turn on or off, because at the weekends or on a bank holiday, they may get an additional amount of time. And so it's very easy then for the parents to turn that on or off. The other thing I need to do is I also said that only the parents can turn the TV on and off. So what I'm going to need to do is I'm going to need to create a new user group for parents and give them whatever access they need. And then whichever user is the parent, they need to be in that group. And then this switch needs to only be able to be authorized by that group. So then the kids wouldn't be able to see it. So let's just go back over the details. So once have the ability to say whose TV time it currently is. Done, radio button. We can see that very, very nicely as well in the app. So we can see TV mode, radio button, adult time or children Tim, because I can't spell. Good job, my child's called Tim. So I could say it's adult time or it's children time. Done. Kids get 2 hours of TV time a day. So it should be comparing their TV time and whether the TV's on and start counting. Done. 5 minutes before, it should play a text-to-speech message that they have 5 minutes left. Done. And then once their 2 hours is up, TV turns off. Done. As the adult of the house, I should be able to turn it back on, but only me. Yep, sorted. And every day this needs to be reset so we can start again tomorrow. Again, already done because a utility meter, that will reset at midnight every day. And on the switch block, I've done a reset into here to turn the TV back, to turn the switch, the relay for the TV back on anyway. So now let's get on to the extra challenge. So occasionally the children are good. So I want a TV coin button in the app that only I can press, which will give the kids an extra 5 minutes of TV time. And so this is where the beauty of me using the utility meter comes in. Because for any of you that have already been eagle-eyed, you'll see that I haven't actually put a value into this equal block yet of 24 or 23 into this one. And that's because what I can do is I can create my bit of logic to change this value as I need it to be. And so I need, first of all, a button in the app. Easiest way to do that would be a virtual input. So let's have a virtual input called Good Children. I can make the authorized users for that, again, the parents group. I should probably also remember to make my admin a member of parents. So I've got a virtual input that I've called Good Children. That's digital and it's just a push button. I now need to put that into something that can count up. So best block for that, probably a counter. Simple counter with limit. And then all I have to make sure is that the limit is super high, that it's never going to be hit. And then again, what I can do is I can reset this counter every day. So every day this counter will get a pulse on the reset, which will reset it back to 0. And then what I need to do with this counter is I need to take the value that's on this counter and add it to 23 and 24. So it would continuously add an extra amount onto here for their allotted time, because we know that 24 is 2 hours. So if I make it 25, so if I add 1 to it, then it's 2 hours plus 5 minutes, 2 hours, 5 minutes. So what I'm going to do is I'm going to have 2 add blocks. And this counter is going to feed into both of those add blocks. There we go. One of these add blocks, I'm going to add 24 to the counter, and that's going to go into my 24 equal block. The other counter, I'm going to add 23 to, and that is going to go into my 23 counter block. And that then is my extra challenge done of 5 minutes of additional time, because it will still then also play the text-to-speech message 5 minutes before their new time is up. And if I whack all of this into simulation to show you, let's take a look. So it's now their operating mode, and the TV gets turned on. And look, utility meter has started counting because the pulses are being sent. So you can already see it's at 0.2. Currently, they don't have any additional time. So this is counting to 24 and this one's counting to 23. But if I want to, if they're good children, I could press pulses in here and you can see that these 2 equal blocks go up to give them additional time. And then you can already see that it would already work, that this would reset the switch when it equals 24. But a pulse for day will also reset this counter back to 0 and turn this switch back on just in case. And there it is, my configuration done and sorted. So all it takes, minus these 3 blocks here, for me is radio button, threshold, both of those into an AND block, into a pulse generator to pulse every minute, a utility meter which counts 5 pulses as 1 unit, so 1 unit per 5 minutes of time. Take the time today, and if that equals our deadline, then it turns the switch off, and 1 unit before it equals our deadline, so 5 minutes before, it plays a text-to-speech message. Job done. So now that that's out of the way, let's move on to our winner. So I have prepared a lovely little config file for the person who is going to win this challenge. So I'm going to save this into my mini server, provided I remember to put a password in there. Here we go. So save this in. So what we have on our winner chicken dinner config file is input 1 of my demo case. When I toggle it, it's going to create a random number on a random number generator that is going to get fed into the output pulse duration of a retractive switch block. The switch block itself is also going to get triggered. That then goes into a pulse generator, which sends a 0.1 second on and off pulse, which goes into a radio button, which will cycle between the outputs of the people who have entered into the draw. So now that this is saved in, let's open this up in config, in the user interface, and let's see who wins. So these are our available participants. Let's see who is going to win our smart socket on this wonderful Friday. 3, 2, 1. And look, no hands, so you can see I've got nothing to do with this. Where it stops, nobody knows. Ooh, can't remember. There we go. Richard Llewellyn, congratulations. You are the proud winner of a smart socket. We will get one sent out into the post for you as soon as we can. Thank you everyone for joining. I hope you've enjoyed, and I will see you again next time. Goodbye.